So when we say implicit, we're on page 7. An explicit function is what we're used to, you guys. We're used to saying if y equals 5x squared, and I were to say, go take that derivative. How can I write the derivative of y? What's a way that we could write the derivative of y? Y prime or f prime if I had put it in terms of f, or d
over d. Yeah.
d y dx, right? Derivative of y is dy dx. Okay, what about the derivative of 5x squared? 10x. Thanks, guys. An implicit equation doesn't already have the y by itself. An implicit equation could be like this. Y over x squared equals 5. And we need to be able to take this derivative still. Is this black equation the same as this red equation that I just highlighted both of them in blue, those colors? Yes. Are they the same? Meaning, could I just multiply this guy by x squared so that these cancel out? And are they technically the same equation? Yes. An implicit equation, just the y isn't by itself yet. And we need to be able to take the derivative of an equation where the y is not yet by itself. We can do this though. So my first thing said, which of the following could be written explicitly? Which of them could be written as just y equals? Could we get my y by itself here?
Yeah.
We could subtract x squared and then cube root both sides, right? Could we get y by itself here? I could divide by x, and you guys don't even have to write this down. Like, I'm just saying, we could get y by itself. On this one, we could get y by itself. So these could be all written explicitly. What about this one? We got a y in two different terms, so we cannot write this one explicitly. No, that's a good point. I see what you're saying. If we divide it by a y, we're actually getting rid of a factor. So he's saying, what about this one?
I don't think so.
Can't do it. I got y's all over the place, so I can't write that one explicitly. That one? Yeah, I actually could factor out a y here. And again, you don't have to write these down, you guys, I promise. I'm just giving you examples. And then I could divide by that x over x minus 3. And I got my y by itself. And then, ooh, does anyone remember this? Do you remember how to solve for y on that? I don't think I got to teach you this last year because I think I was on maternity leave. We'd e both sides. So then it'd be y equals e to the x squared minus 3x. And I got y by itself. So these were the only two that were implicit. So if we're just finding the derivative, what I do want us to get used to, instead of saying y prime, if I'm finding the derivative of this, I do want us to say dy dx. The derivative of y is also dy dx. What would that derivative be here? We've done this in our sleep now. Negative 18x to the, beautiful. What about this little cutie over here? Would I have to do quotient rule if I left it like this? And the answer is yes. And quotient rule is annoying. I know it's my favorite because it involves me, but quotient rule is annoying. How could I rewrite this so that I don't have to use quotient rule? Yes. He's saying, oh, negative 1/3 x cubed. Are these the same thing?
Yeah.
Yeah. And then I don't have to use quotient rule because I can just use my power rule now. I can just use the power rule. What is negative 1/3 times that exponent of 3? Negative 1 x to the second. What's the derivative of y every time? We got to just remember the derivative of y is dy dx. That is muy importante. Okay, so now I gave you I gave you an equation where my y isn't by itself. I could get my y by itself, but I want us to try. I just want to show you what it means if my y is not by itself. We do the same thing, guys. What is the derivative of x squared? 2x. Cool. What's the derivative of y squared? And again, just treat it like a variable. Yeah, he says, all right, if the derivative of x squared is 2x, the derivative of y squared is going to be 2y. I agree. But we got to know. We just took a derivative of y, yeah? What do we have to put after anytime I take the derivative of y? A dy dx. And you're like, excuse me, what? Follow along. I promise I've got a rationale for you in just a minute. Derivative of 25 is 0. Okay, you're like, squeeze me? Where the heck did this just come from? Chain rule is where it came from. Here's the deal. Here's what we actually did, you guys. In this right here, we've got this inner and then this outer, if you will. The derivative of x squared, we just say is 2x. And anytime we take the derivative of a variable, if I'm taking the derivative of an x, you say, okay, I'm going to take the derivative of that variable with unmute me. It's always going to be with respect to x. So I said that in a very confusing way. The derivative of x, we always know is 1 because it's technically dx dx. Anything over itself is always just 1. So I never have to follow the derivative of an x with a dx. Let's go back to y now. The derivative of a y, we've got the derivative of y squared. We treat it like a normal function, which would be 2y. But what's the derivative of my inner? What's the derivative of a y every time? dy dx. Oh, are we going to forget that? Yeah. We're going to have to practice this a lot. Let me say this one more time. Whenever I said, hey, if I gave you y, what's the derivative of that? It always has just been dy dx because it says, oh, it's got to take the derivative of this function with respect to x. So that's why it's always been dy dx. When I ask you to take the derivative of an x, you say, oh, I'm taking the derivative of that function with respect to x. Dx dx always cancels out to be a 1, so that's why we haven't needed it. So I'm going to say that one more time. The derivative of y squared is going to be a 2y. Leave the inner. We just did that. And then we got to multiply by the derivative of the inner. Right now, you could be super confused with that. Just bear with me. Let's keep going with it, and we'll practice it, and I promise that it will get more fluent. It says find the slope, the dy dx, which we just got, at any of these points. So let's go get dy dx by itself first. Could I subtract 2x? We're allowed to do that. And then how would I get dy dx by its lonesome? Divide by 2y. Negative 2x divided by 2y. My 2's can cancel, and we're just left with negative x over y. This is the equation of a circle right here. This is the slope of this circle at any point. Weird. Let's go plug in the point 0, 5. Looking at this picture, 0, 5, what do you think that slope's going to be? 0. Let's go plug in 0, 5 to this equation and see if we get a slope of 0. So what I would do to note what we're doing is I'd say dy dx at 0, 5. I'd put this little evaluation bar to say I'm evaluating my derivative, which is right here, at 0, 5. I'm going to plug a 0 in for x and a 5 in for y. So I'd get negative 0 over 5. What's that going to simplify to be? 0. You guys, didn't you just predict that the slope there was going to be 0? Yeah, you did. They want us to find the slope at 3 different points. 0, 5, 3, negative 4. So how I'm going to note that is I'm going to say, all right, I'm going to go find the derivative at 3, negative 4 this time. And this helps the reader know what numbers you're plugging in where. I'm going to plug a 3 in for x and a negative 4 in for y. What would you get? Negative 3 over negative 4, so final answer, 3/4. At 3, negative 4, 3, negative 4. Does it look like my slope is going to be positive something? 3/4, sure. Sounds good. And then finally, they had one last point, negative 5, 0. The derivative at negative 5, 0. The slope of that curve at negative 5, 0. When my x is negative 5 and my y is 0. Yeah, 5 over 0 would be undefined. What's the equation look like, or what does the line look like that's got an undefined slope?
Vertical.
At negative 5, 0, does it look like it's got a vertical line slope? And that's how it worked out. Holy smokes, people, we got this, we got this, we got this. On number 5, we got to take the cosine of y. Cosine is my outer, sorry, the derivative of it. Cosine is my outer, y is my inner. What's the derivative of the outer? Negative sign, leave the inner, times the derivative of the inner. The derivative of y all day, day is dy dx. Good job, you guys. We did it. We just chain ruled with implicit differentiation right there. Awesome. Now we just keep going. Derivative of 3x. 3, we feel good about that. The derivative of 3y. 3, and then the derivative of a y is dy dx. The instructions on this one said go find dy dx. They want us to get dy dx by itself. Correct me if I'm wrong. I got a dy dx over here and a dy dx over there. I got to get them on one side. Do you want to move all this thingy to the right or all this thingy to the left? You want to move this thing over? But then I have a 0 over here, right? Which is okay. I would have to move my 3 over. It's up to you. Are we adding this part over? I'm fine with it because then it'd be positive. Okay, so Ritzy's saying, let's go add sine of y, dy dx to both sides. And what would I have to subtract? I'd have to move that 3 over because it doesn't have a dy dx, right? So I'm also going to subtract a 3 from both sides. So I'd have a negative 3 equals 3 dy dx plus sine of y dy dx. Okay, then what you got to do you agree both of these terms have a dy dx in common? Can we factor it out on that right side? So my negative 3 is chilling. I got a dy dx. What's left? If I factor out a dy dx, exactly, times 3 is going to get me 3 dy dx plus a sine y, because dy dx times my sine of y would get me what I started with there. And then how do I get dy dx by itself? I got to divide by what it's being multiplied by, which was a 3 plus sine of y. My final answer is negative 3 over 3 plus the sine of y. And that's my slope. What? That is the slope of this curve anywhere. Okay, we got this, people. Derivative of tangent. Anyone remember derivative of tangent without looking at my cheat sheet? Secant squared, you're getting good. Derivative of tangent is secant squared of my angle times the derivative of my angle. Dy dx, very good. Whoa, the derivative of x cubed. 3x squared, you got it. Derivative of 9. 0, and the derivative of 0. Good. You want to know a lot of people mess up? They'll take this derivative perfectly, they'll take this derivative, and then they'll write plus 9. Because we forget. Like, we're doing hard stuff, you know? Okay, they said find the value of the derivative. They want dy dx by itself. And then go plug in negative pi over 4. I say let's go get dy dx by itself first. Sound good, people? Let's go get dy dx by itself. So, could I subtract 3x squared? So I got secant squared y times dy dx equals negative 3x squared. Then I can divide by the secant squared. Agreed, buddy. Not that we need to. Does anyone know what that would simplify to be? What's 1 over secant? Secant is the reciprocal of cosine, isn't it? So couldn't we technically say this is the same as 3x squared times cosine squared? You don't have to, but I'm just reminding you like you could. Okay, then they said find what the derivative is, which we have right here, when y is negative pi over 4. So I can put a negative pi over 4 in right there, but what would I put in for x, or how would I figure that out? Say it again. Yeah, we don't know what the x is. They say just when y is pi over 4. If here's my function, yeah, and my y is negative pi over 4, couldn't I plug it in over here to solve for my x? We're going to need to do that. Whoa, okay, here we go. Some blast from the past. This is a heavy Friday lesson. Wow. Tangent of negative pi over 4 plus an x cubed plus a 9 equals 0.
Luckily, the pi over 4 tangent is always 1.
Okay, you're right. Tangent at pi over 4 is 1, but just be careful because it's negative pi over 4. If I'm looking at a unit circle, we got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Isn't negative pi over 4 going down?
So,
And wouldn't those always be positive than negative values? So if I had to do my y over x, positive 1 or negative 1? It's going to be a negative 1. Awesome, Coop. Negative 1 there.
well, no.
Oh, okay, let's see if we get the same answer, bud. Oh, can a cube be negative?
No.
Cube. Yeah, odd exponents we can. We can because what's the cube root of -8? Meaning what times itself 3 times gets me a -8? This one is a -2. -2 times -2 is 4 times -2 gets me -8. So now I know what to plug in. Boop, boop, right there. So my slope would be -3 times -2 squared times the cosine of my y one more time was -pi/4. And I'm actually going to write this way so that I remember to square that whole thing. That squared, same as that squared. PEMDAS says I got to do this exponent first, so I'd have 4 times -3 is -12 times, what's the cosine at -pi/4?
Root 2 over 2.
Positive root 2 over 2. Very good, sir. Root 2 over 2, and then we got to square it. Is this multiple choice? No. Let's act like it was, and then I'll show you where we could have ended. -12 times, what's root 2 squared? 2 over 2 squared? 2 over 4.
So it's 1/2.
-12 times a half?
6.
Ooh! -6. Coop, I think often you write the negative, you just don't say it out loud. Is that true?
Yeah.
Yeah. Okay, where could we have ended? We could have ended right here. My girl Ava's going to end right here.
Oh, yeah.
We could end right here. So AP will give you this, and notice this is part of a free response. And look what they're saying. Show that this derivative is that. They're telling you what the dy dx is. They're giving you the final answer. We just got to go through and show them, oh, we can get that. We can do that. And look what they do. They do that right there. They did it right here. This was 2021, people. Whoa, okay. Which one would you rather do first? I don't care. Do we want to do 2021 or
2004.
2004?
Yeah, 2004.
2004, here we go. Here we go. They gave us the answer. It's like me giving you the answers. We just got to get there. We can do it, people. Derivative of x squared. What do we got? 2x. And how do I know to take the derivative? Because they said, here's this function. Show that dy dx is this. If there's a dy dx, I know I got to take a derivative. Be careful now. The derivative of 4y squared. 8y dy dx. So good, Ritz. We okay with that, Harvey? That's what it was. He was like, why iota? There's still product rule. Don't worry, this one's not as hard as the other one because the other one had a negative sign. Harvey, what's the derivative of 7? Good. So now you're saying this which, I'm the which, is still making us do product rule. Here's what I want you to think about, Harville. Make this 3x the f, make the y the g. For my fig plus gif, make the entire first function 3x the f. Okay, so let's go f prime times g. What would f prime be if f is 3x? 3 times g, y, plus g prime, be careful. 1, the derivative of y is 1 dy dx. So I'm just going to say dy dx. We have to remember the derivative of y is always a dy dx. Times g. I'm sorry, that was g prime times f. Times 3x. I'm going to underline what we just did here. That was f prime times g plus g prime times f. All they want now is us to get all my dy dx's on one side. Let's start with that. You agree 8y dy dx. Can we leave it over here? And then should we bring over this one?
Yeah.
Okay. And then I got to move my 2x to the other side. Okay with that? So I'm going to say I got 8y dy dx.
Wait, where's the 7?
Oh, derivative of 7. Don't forget, you got to take the derivative. Yep. I'm going to say minus 3x dy dx equals 3y minus 2x. Do both of these have a dy dx in common now? Can I factor it out? Yes. I'm going to take out a dy dx. And what's left? Yes, 8y minus 3x.
Yeah, we get thing in the issue.
To get dy dx by itself now, we can just divide by 8y minus 3x. are we going to write my dy dx equals what's left? 3y minus 2x over 8y minus 3x. Did I prove what they wanted? Because it says